Hello, this video is about the final presentation of the data science programming project. The project is recognizing emotion from EEG data. This is done by team of three, Harika, Mohanaditya and Nivedita Mangal. So if we talk about the contents that I'm going to speak in this presentation, I'll give a brief introduction about the data that we have and how is it scattered, and I will explain about the approaches that we took especially in creating machine learning models. Later on I'll also explain about the PCA done on the data set to try to improve the accuracy of the model, and at the end we have also tried LSTM networks, which are still work in progress. We are still learning many other factors and trying to execute it. And also I'll be talking about the improvements that can be done going forward. So the data set is about the data set is collected by placing 40 sensors on the head of every person, and after they place the sensors on it, on the person's head, the person was made to watch a video, and then the person gave the rating for a video on a scale to of 0 to 10. Now we use this data to come up with models that could actually understand the pattern of what the person's feeling was while the person was watching the video, and accordingly predict what accordingly understand what type of emotion the person is going through. So the test had 32 patients who watched 40 videos, and there are that means we have 1280 samples. Now each person watched for 1 minute, and we have 7860 rows of 1 minute video. So at the end we had little more than 3,14,000 rows and 40 columns, which is pretty huge data set. Now this is about the X thing, and now about the dependent variable. So the person gave a rating on 0 to 10, which says about the amount of arousal or amount of arousal he had while he was watching the video. So we created it into a binary class by taking arousal deactivated as those videos where the score was less than 5, and arousal activation as those videos where the score was greater than 5. And in this way we have 754 videos which were aroused or which had arousal activation, and 526 videos which did not have arousal activation. So our first simple approach was to try to come up with a mapping system, because for 7860 rows we have one outcome: arousal activation or deactivation. So we thought the best and simple model to start with is to take the mean of these 7860 rows, and in that way we will have the same amount of independent rows and the same amount of dependent rows. So we took mean of each attribute of each video, and hence we are left with 1280 rows on the independent side and 1280 on the dependent side. On this we try to create classification models, especially using a random forest, MLP, and also because we had very less number of rows, we went ahead and applied k-fold cross validation. The results look okayish, because crunching down 7680 rows to just one row is like we are missing a lot of information. But still we were having train accuracy of 64% and test accuracy of 62%. This says that the model did not overfit, but the problem here we were facing was the scores of precision. Although the model was having a decent recall score, there are more false positives, and hence we had a lesser precision score. So we thought maybe applying PCA on the rows might reduce the number of dimensions, the number of rows, but still keep the information intact. So we applied PCA on one video and found that 15 components explain 90% of the variation in that video. So we went ahead and modeled the PCA on each video, and hence we are left with 19,200 rows of X, whereas the Y was just having 1280 depending. This approach did not seem very useful because the model has heavily overfitted with 100% accuracy on train, but just 0.5% on test, which is nothing but a zero in case of classification. So we thought about LSTM because we felt that the data is timely dependent, because the 1 minute video, because the sensors output rows every second, every tenth of a second. Because of that, we thought maybe LSTM networks will be the way to approach this issue, as LSTM networks are time-based networks. So we started understanding more about LSTMs and how they can be coded and the architecture. We built one basic architecture which was just having accuracy around 55% on the test, and it was first hit on LSTM. But later on we have modeled a much deeper network with 2 layers stacked along each side, and along with the weight and bias additions. So I'll quickly go through the parameters that we have used. We have used categorical cross entropy because it's a classification, and we used Adam optimizer for differentiation, and then we used a ReLU activation function. We have trained the model for 30,000 iterations, and we just used the input batch size as 128. This was it actually took us a lot of time to train these networks, and we are slowly understanding how to implement LSTMs on such datasets. For now, the accuracy of the model, even though after so many iterations, is just around 54% on the test dataset. This is still an ongoing project, and we are planning to continue it in the summer, and we'll keep you posted about this. So the improvements that we felt we could do was that to create even more deeper LSTM networks and understand how there's very little information on how these what are these sensors and how do they capture. So if we are able to understand the data better, then we could do a better job, and also think about any other features that can pertain in the rating of a person giving the rating. As this is a wide issue where it's really tough to understand the feelings just from 40 sensors on a person's brain, we were expecting that we would not be able to build a great models. We would not be able to build great models. But still, this was a very interesting thing for us, and we went ahead and tried. Thank you so much for giving us an opportunity to work on such interesting projects, and also thanks for all the support. Take care and stay safe.